Hi guys, we are on day 10 of our notes, the continuation of what to do when we are rationalizing denominators that looks like this, where there are two terms, maybe there's a plus or a minus in between them, and we need to rationalize the denominators, meaning get rid of the radical in the denominator. Well, we're going to use something called conjugates. So conjugates are two binomials of the form a plus b and a minus b. They're with radicals right there. And they are called conjugate radicals. So they look exactly alike except for one of them's a plus and one is a minus. So skipping on down here, like if I have 2 minus the square root of 3, its conjugate is 2 plus radical 3. Same thing with cube roots. If I come on down to find the conjugate of each of the following, it's as easy as just changing the operation in between the terms. So that's the conjugate of -1 plus radical 7. So those are each conjugate pairs. Now, the idea of why a conjugate is important is because of what we're going to look at number 2. If I take 10 plus radical 5 and multiply it by its conjugate, let's see what happens when we FOIL. 10 times 10 is 100, minus 10 radical 5, plus 10 radical 5, minus radical 5, and radical 5 is 5. Now what I want you guys to notice is that these terms are going to drop out, those inner and outer terms, which means the radicals disappear. Now you're left with 100 minus 5, which is 95, which is a rational number. Okay, so conjugates are awesome because, again, when you multiply them together, they create rational numbers. So coming on down to number 3, if I were to say, what's the best approach to start this problem, I would look for conjugates. So I would actually start by multiplying 1 plus radical 7 times 1 minus radical 7, because I know that when I FOIL, the inner and outer terms will drop out, which means I only really need to calculate the first and last terms together. Whoops, this should say 7, because the square root of radical 49 is 7. So 1 minus 7 is -6, and then I can take that -6 and distribute it to the other part of this binomial. This is -6 minus 6 radical 7, and that would be your final answer. Okay, so coming on down. Now we're ready to rationalize the denominators. We are going to multiply the numerator and denominator of the fraction by the conjugate of the denominator. So for number 1, I'm going to multiply top and bottom by 4 minus radical 11. Now in the numerator, we're just simply distributing. In the denominator, here's your FOIL, except just the first and last. So 4 and 4 is 16. Radical 11 and radical 11 is 11. I'm just going to work to clean this up. 8, 2, 5, none of those are reducible by a common factor, so that's your final answer. Now again, the reason I'm not completely foiling here is because, look, if you were to actually calculate your inner and outer terms, that's 4 radical 11 minus 4 radical 11, they would drop out. That's the whole point. So if I come on down to number 2, I'm going to multiply top and bottom by 4 plus radical 3. Now in the numerator, these are not conjugates, so we're going to completely FOIL out like normal. In the denominator, these are conjugates though, so I can do a little bit of a shortcut. So I get 11 plus 6 radical 3 over 13. Again, all these numbers are not divisible by the same number, so that's as reduced as it's going to get. And that's your final answer. Conjugate. Conjugate. Now in that numerator, you're going to take this 2 radical 5 and distribute him to each part of this. So that is 2 times 1, which is 2, radical 5 times radical 5, which is 5. Now times 1, which is just itself. In the denominator, I just have to do the first and last. 5 minus 1 is 4. Now at this point, guys, you can reduce each of these by 2. So my final simplified answer is 5 plus radical 5 all over 2. And then you're done. Okay, just a couple more examples here. Now, it's really important to note, guys, in the numerator, these are not conjugates, so you have to completely FOIL those out, okay? So this is radical 7 and radical 7, which is 7. And then I get a radical 21 plus a radical 21 again from my outsides, and then my last give me a 3. In the denominator, these are conjugates, so this is just 7 minus 3 by calculating the first and the last. Now again, just like last time, I'm going to see if I can reduce each of those. Each of them reduces by 2. And so I end up with 5 plus the square root of 21 all over 2. And the square root of 21 didn't break down at all. That's just 7 and 3. Those aren't perfect squares. All right, at this point, I would encourage you to pause your screen and see, or pause the video, I should say, and see if you can do number 5 yourself. If you want to keep watching, though, I'm going to do it now. All right, so at this point you've probably unpaused or you never paused and you just watched me work through this. You'll notice in this example, each of these coefficients was divisible by 1, so at the end of the day, you should have ended up with radical 5 minus radical 2, and that's your final answer. So again, just to recap, whenever you have denominators with a binomial, you're going to multiply by the conjugates. If you have something that looks like this, though, which we talked about previously, you can just multiply by whatever that denominator is, and it completely rationalizes it. Or you could do something like this, like if I had 2 over radical 12 and I wanted to rationalize that, I could multiply by a number that would create a perfect square. Oops. And then reduce. So just food for thought there, okay? So these are when you have the monomial denominators. This is when you have the binomial denominators.